Hello, I am Ankit Alex Hansda. You are 15 CS to 58, and I am making this video to explain about the experiment 5 that I made for Data Structure Lab. The aim of this experiment is to implementation of stack and queue using linked lists. So first we will include the required header files, iostream. Then I will make a structured node that is in that and which have data members data and next. See, this next part will store the address of the next element and data will store the data, and we will initialize our value top. So this top value has to remember that is that and no next, and its main function is to point towards the starting of the that is topmost element of the list. Next are the functions, that is push, pop, and display. I have initialized it here, and next we will define them. So first is push function. In this push function, we will enter the elements inside the list, and the new elements will be appended at the top of the list. That is at the uh, top of the stack. So whenever new element is entered, it will be stacked at the top of the list. So first we will make a new element, then initialize its values, and first we will check whether the list is empty or not. If it is not, it is empty, we will make it top, or else we will feed its address to the top address part of the top, and we will feed the address of top into the new element and make the new element top. So using this method we will we have successfully appended a new element at the top of the list. Next is pop function. In the pop function, what we will do is we will delete a function from the top of the list. So whichever element has come last, it will be popped out first. So we will implement the concept of stack, that is LIFO, last in first out. So first of all we will check whether the stack is empty or not, and if it is not, then we will delete the topmost element of the list using these commands. Next is display. For display, we will transverse from the starting of the stack to the end of the stack, and while printing every one of the stack, every one of the element. So we have defined our major functions. Next is main function. In main function, first of all, I will make a menu, so which will ask the user to either insert, delete, or display from the display or exit from the program, and this command should respectively execute those choices, and that's it. That's it, the definition of the program. Now let's try some samples. So first of all, I'll insert 5 elements. So we have currently 5 elements in the stack, and 5 is the last one. So if I try to display it, as you can see, 5 is at the top of the stack. Now if I delete, 5 should be deleted. So as you can see, 5 is deleted. Now let's try displaying it again. So 5 is deleted, hence only till 4 we are seeing the stack is present. So as you can see, we have successfully implemented stack. So moving on to the next part of the program, we will use linked lists to implement the queue function. So the first part of the program will be similar to the stack and the linked lists. Then I will initialize the functions, that is enqueue, dequeue, and display. So first defining the enqueue function. So similar to the stack, we will the only difference between stack and queue will be we will have two variables. Like we had top there, we will have front and rear here. So the front will always point towards the top of the list, and rear will always point to the end of the list. So now we will use enqueue to input the element at the bottom, that is at the end of the list. So first this part will be similar to the last one, because we will make the new node and initialize it. And if the bottom part is null, that is if both are null or either one of them is null, then we know that the list is empty, and we will make rear make the element both rear and front, because there are only one element. And if it is not, then we will append it at the bottom, that is at the after the rear one. So after the rear, we will append it after the rear element. So after the last element, it will be appended, and then the new element that we have inputted will be now become rear. So the rear will always point towards the end of the list. That's how this enqueue will work. Now moving on to the dequeue. In this function, first we will check whether the queue is empty or not, and if the list is not empty, what it will do is it will delete or pop out or exit an element from the top of the list, because whenever a new element is whenever it is entered at the list, it is entered at the bottom. So the element which has been entered earlier always gets pushed to the front of the list. So if an element is pushed first, then it should be taken up first in the queue. So the front will always point towards the first part of the element. So what we will do is we will delete the first part of the element, and then the front will point at the second part of the element, the second element of the list. So that's how these two functions work. In the display, it will be similar to the last program only, but the thing is, we will start from front and we will go till the end of the list and print it out. That's how all the functions work. And now in the main function, I have again made a list. It will ask from the user to either insert, delete, or display, and will execute as per the user choice. So let's try out one sample. So first let's insert 5 elements similar to last one. So we have inserted 5 elements. Now let's try displaying it. So as you can see here, 1 2 3 4 5 5 elements are there which we have inserted. Now let's try deleting one. So the first element, that is 1, which we inserted at the first, has been deleted first. So the concept of queue is successful here, that is first in first out. And if we display it, the one is not anymore in the list. So the queue has been successfully executed. Thank you.